Welcome to a new section. Today we are going to study Gauss's law. Gauss's law says about the electric flux through a closed surface. It states that electric flux phi through a closed surface is 1 by epsilon 0 times the total charge enclosed in that surface. Here Q is the total charge enclosed in that surface. We know if E is the electric field through an area element ds, then the electric flux d phi through that area element is E dot ds. Then total flux phi through that closed surface is closed integral E dot ds. And by Gauss's law, it is equal to 1 by epsilon 0 times the Q. So this is the statement of Gauss's law. Before going to prove this Gauss's law, we are going to say some important points related to Gauss's law. First, Gauss's law is true for any closed surface. It doesn't depend on the shape or size of the closed surface. So this surface we are considering here is called Gaussian surface. Now look at the equation. We are having two parts for this equation. One is left hand side, that is closed integral E dot ds. We have to remember, in this left hand side, electric field E is the electric field due to all charges existing in the space. That means it doesn't depend on whether the charge is inside or outside. The electric field E is due to all charges, those who are inside or outside the closed surface, we are considered here. But the second part, that is RHS part of this equation, that is 1 by epsilon 0 times the Q. In that, Q is the charge enclosed inside the closed surface. That is, here we are considering only those charges which are inside the closed surface. The charge may be located anywhere inside the surface, but it must be inside the closed surface. We are not considering the charge outside the closed surface in this Q. We are only considering the charge inside the closed surface, and that can be anywhere inside the closed surface. So we understood what is Gauss's law. Now we are going to prove this Gauss's law by considering a simple case. For that, consider a sphere of radius r and a charge q is placed at its center. So this radius is r. Consider a small area element ds on the surface of the sphere. Let E be the electric field through this area element. Then electric flux through that small area element ds, which is denoted as d phi, is equal to E dot ds. We know this electric field E is due to this point charge Q placed at the center, and that is equal to 1 by 4 pi epsilon 0 Q divided by r square into r cap, where r cap is a unit vector along the radius vector from the center to that area element. Therefore, the electric flux d phi is equal to this dot ds. We can also say the normal to a sphere at every point is along the radius vector at that point. So, the outward normal to the area element ds is in this direction. That is, the unit vector r cap and ds are in the same direction. Therefore, what is r cap dot ds? Here theta is equal to 0 because r cap and ds are in the same direction. Therefore, cos theta is equal to 1, and we know the magnitude of unit vector r cap is 1 because it is a unit vector. Therefore, r dot ds is equal to magnitude of r cap, it is 1, into magnitude of ds, which is ds, into cos theta. Here cos theta is 1. Therefore, r cap dot ds is equal to ds. So, this equation, that is electric flux d phi, can be written as 1 by 4 pi epsilon 0 Q divided by r square into r dot ds, which is simply ds. So, we got the electric flux d phi through that small area element ds is equal to 1 by 4 pi epsilon 0 Q divided by r square ds. Total electric flux through this closed surface can be found by integrating over that closed surface. So, we got the closed integral d phi is equal to closed integral 1 by 4 pi epsilon 0 Q by r square ds, and that is phi is equal to 1 by 4 pi epsilon 0 can be taken outside. Q and r are also constant, so it can also be taken outside. So, it is closed integral ds. We know ds is a small element on the surface of the sphere. So, if we are finding a closed integral of ds, we are getting surface area of a sphere. So, this equation becomes 1 by 4 pi epsilon 0 into Q by R square into surface area of a sphere. And we know surface area of a sphere with radius r is 4 pi r square. Cancel off 4 pi and r square. We are getting 1 by epsilon 0 times the Q. So we got the total flux through a closed surface is phi is equal to 1 by epsilon 0 times the Q. We know we took Q is the charge inside that closed surface. So thus we prove the Gauss's law. Remember, here we prove this Gauss's law by considering a simple case, that is by considering the Gaussian surface as a sphere with a charge Q placed at the center of that sphere. We can also prove this Gauss's law by assuming Coulomb's law. We will study that proof in another video. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.